Hi everyone, welcome to the first video on light reflection and refraction problem solving. So in this video, before we start with the problems, we will discuss the sign convention to be followed whenever you are approaching a question. So here is, let's say you are considering these as your x-axis and your y-axis, and this will be your origin, okay, usually. Then to the right, all values taken to the right of this origin is positive, to the left of the origin is negative, downwards it is negative, to the top it is positive. So whenever you do any question related to light reflection or refraction, be it mirror or lens, you will be following this sign convention. That is, anything that is taken to the right is positive, to the left is negative, to the top is positive, to the bottom it is negative. So when you place a mirror, let's say this is a concave mirror, right? This is a concave mirror. How do you identify? It is the inside, just like a cave that is towards the inside. The inside part of the mirror is reflecting. So this is a concave mirror, and I will make sure that this concave mirror has its here. Here is O. Understood? So the position of the mirror is at the origin. So any values taken to the left is negative. Let's say I'm placing the object here. Okay, what are the letters that we use to represent object and images? The object is usually denoted using U, and the image is V. Okay, easy way to remember, in the alphabetical order, V comes after U, which means the image comes after the object. First you have to have the object before you have the image, So yes, so this object is U, image is V. So in this case, let's say this is placed at a distance of 20 centimeter from the mirror. Okay, let's consider this image, this object is placed 20 centimeter in front of the mirror. Then this mirror will have its focus here, center of curvature here, that we know, right? But here, the object is on the left side. So when you write the value, you will write U is equal to minus 20 centimeter. Okay, now you can take different values. Let's say it gets reflected here, it moves through the focus. So the focus is also on the left side. So let's say the focus is at 15 centimeter. Then you will write F is equal to minus 15 centimeter. Okay, and let's say the image is formed at somewhere here. Image is formed at somewhere here. Upon calculation, you will see that your image value V is also negative. You see that? Okay, I'm not approaching I'm not doing any particular question now. It is just to tell you how to approach a given question. Here, let's say this concave is finished. Now let's look at this convex mirror. In case of convex mirror, this outside part of the mirror is reflecting, right? See, the inside is hatched, which means this is a rough part, and this outside part is a reflecting part. So since the mirror is facing in the opposite direction, it is obvious that the focus is not here. The focus and center of curvature will be on the right side, so it will be mostly positive. Then the object is placed on the left side of the mirror always. In all the question, the object is placed on the left side of the mirror. So that is taken by convention. That's why I'm writing sign convention. Okay, the object is placed on the left side of the mirror. So here also, let's say it is placed at a distance of 20 centimeter. I would write U is equal to minus 20 centimeter. Here given F is 15 centimeter, but this time the focus is on the right side. So I would write F is equal to positive 15 centimeter. Okay, then you can, upon calculation, you will see the value of V as negative or positive. That will depend on the question. And this is a sign convention for concave and convex mirrors. Now let's look at lenses. Here is sign convention for lenses. So what kind of lens is this? You see everything is outwards here. So this is a convex lens, right? The convex lens, because it's outwards. Here it is inwards. Whenever it is inwards, like in a cave, this is a concave mirror. Concave lens. Yeah, this is a concave lens and that's a convex lens. Here also you will follow the same sign convention as that of a mirror. Only thing, the distance, the focus in this case, if you remember when we learned the concepts, here is the object which is on the left side of the lens, so this is going to be negative. And I told you when the line is, if I take a line parallel to the lens, after refraction, it appears to move away from the focus, right? That's what we learned. It appears to move away from this focus, right? It goes like this. So even if there is a focus here, we don't need to consider it really. So the focus is always taken as negative. The focus is always taken as negative for a concave lens. Why is it? Because it diverges with respect to this particular focus, not anything else. This focus is not under consideration. But here, let's say this is the focus of, they have two foci. So I'll keep an object here. You will see that if you take a straight line, after reflection, it will move through the focus on the right side, not the left side. This is not considered anywhere. So the focus here is always positive. All other signs that relates to image or the object or image or whatever be will be same as that of this mirror, which is you follow this sign convention. Everything towards the right is positive, left is negative, top is positive, bottom is negative. Okay, this is the only change when it comes to lenses, where the focus on concave lens is on the left side, so it is negative, and the focus on convex lens is on the right side, so the focus is positive. Understood? So whenever you approach a question, this is the first thing that should come to your mind, that is selecting the signs for each focus or optical center or image or distance, whatever it is, you have to pay attention to the sign convention, otherwise your answers will be completely wrong. Now let's move on with the with mirror and lens formula, then we'll start doing some problems. Please note it down. Here are two most important formulae in this chapter. One is the mirror formula and the other is lens formula. So see, mirror formula says 1 by v plus 1 by u equal to 1 by f. And for lens, it is 1 by v minus 1 by u is equal to 1 by f. So how do you remember this formula? Let's say this mirror is a very positive thing in your life. Everybody likes to see themselves in front of a mirror. So it's a very positive thing. So I'll make mirror formula as 1 by v plus, okay? 1 by v plus 1 by u is equal to 1 by f. The magnification, how much the image has, enlarged or is it diminished with respect to the object, right? I'm comparing the size of the image with respect to object. So the object height should always come in the denominator, or height of the image divided by height of object is h dash by h. Height of image is usually represented by h dash. Or it is also, you can also get the magnification by m is equal to minus of v by u. Okay, you don't have to go with the derivation of this. You only have the formula to learn, that is magnification m is equal to minus v by u. So how to remember this one also? If it is positive here, then magnification here will be negative. Similarly, for that case, nobody likes to wear a lens. So it's a negative thing. Let's say it's a negative thing. So I'm talking about how much you like wearing a lens, okay? So that's why it's negative. So 1 by v minus 1 by u is equal to 1 by f. Here also magnification is height of the image with respect to height of the object, so h dash by h again. Or I told you if it is negative here, it will be positive here. So m is equal to simply v by u. Here it was positive here, that's why it is negative. Not that is why, there is one way of remembering things. If this is positive, this will be negative. If this is negative, this will be positive. Okay? So shall we start doing questions? Alright, so please note it down. Let's move on with the questions now. Here is question number 1 from the textbook, that is example 10.1. It says a convex mirror used for rear view on an automobile has a radius of curvature 3 meter. If a bus is located at a distance of 5 meter from this mirror, find the position, nature and size of the image. Most of the questions will be ending like this. You have to find the position, the nature and size of the image. Let's see. So what are the things given? It has a radius of curvature 3 meter. What kind of a mirror is this? It's a convex mirror. Here it is given as convex mirror, but if it's an application level question, it will simply tell you that the mirror is a rear view mirror on an automobile. Then you will have to understand that whenever a mirror is used in case of an automobile, it will be convex and not concave. So here it is already given. So let's say a convex mirror is used. So like I told you for sign convention, see, a convex mirror is placed like this, okay, because this is a reflecting surface, so the inside is the rough surface. If the mirror is placed like this, then the radius of curvature will be on the right side, no? This will be your radius of curvature, no? Radius. So will it be positive or negative? Yes, it will be positive. It's given as positive 3 meter. Okay. Now, if a bus is located at 5 meter from this mirror, bus is located at 5 meter, which means there's an object here. So if this is the pole, the bus is here to the left side. So let's say the bus is somewhere here and it's at a distance of 5 meter towards the left side. So will it be positive or negative? Yes, you're right. So it will be negative 5 meter. Okay. Now you have to find the image distance V, height of the image h dash, and the focal length. Yeah, focal length you don't have to find. That's not part of the question. The focal length can be derived from here. If this is the total radius, then the focus will be half of it. Is r by 2. So this will be r by 2, which is positive 3 by 2 meter. Now substitute in the in the lens formula. What's the lens formula? Oh, sorry. Now substitute in the mirror formula. What is mirror formula? Let's say it is very positive to look at a mirror, so it is positive 1 by v plus 1 by u equal to 1 by f, and you have to find the image distance. So 1 by v is equal to 1 by f minus 1 by u. What is 1 by f given as? 1 by 3 by 2 minus 1.5. Sorry, minus 5. See? Alright, that is minus of minus, this becomes plus. This goes to the top, so this will be 2 by 3 plus 1 by 5. Let's take LCM, you get 10 plus 3, 13 by 15. Correct? Yeah. So you get 1 by v is equal to 13 by 15, or simply you can write v is equal to 15 by 13. When you cancel 13 goes in 15 how many times? 1 time, okay. The remaining is 20. How many times in 20? Again 1 time, remaining 70. How many times in 70? 13 5s are 65. So let's stop it here. 1.15 meter. It is positive, which means, you know, in case of a convex mirror, the object is on the left side, okay, but the image, you see, it is a positive value, right? It is a positive value. It is somewhere here. It's on the right side, so it is behind the mirror. So when they ask you the nature, it is virtual. It's a virtual image because it is on the right side of the mirror, which is behind the mirror. Okay, in case of a convex, it is behind the mirror. All right, now the next thing you have to find out is, nature is ready, position is also with you. Now you have to find out the size of the image. Okay. Size of the image means they are asking for h dash, right? We know magnification m is equal to h dash by h, okay? Height of the bus, do I know? No, I don't know the height of the bus. Next thing I can do is magnification is, this is positive here, so minus v by u also I can do. So minus 1.15 divided by, how much is u? U was given as negative 5, okay? So this cancels, so 1.15 by 5 is equal to 0.115 by 5, 11, 2 times in 11, and 3 times in that, and it will be 0.23. Okay, so you get the magnification as 0.23. You don't, because the size of the object is not given, nor the size of the image you have found out, you cannot use this formula. Okay, let's forget it because we have other methods to solve. You have m is equal to minus v by u. With that, you found out the magnification to be 0.23. You see that the magnification is less than 1. Okay, less than 1 means 100%. Here, it is only 0.23 of the total image. That is only 23% of the total height of the object is shown. So it is a diminished. It's a diminished image. Obviously, because your bus, it's a bus, you can't see the bus in full size. Okay, it's a rear view mirror, so it has to be diminished. You see, the magnification here is diminished. So all things are with you right now. You have the position, you have the nature, it is virtual, and the size of the image is diminished, or you can say it is only 0.23 or 23% of the object size. Okay? Yeah, so let's move on to the next question. Okay, let's look at question number 2. An object 4 cm in size is placed at 25 cm in front of a concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and size of the image. Okay, what kind of image is this? It's a concave mirror. So when you draw a concave mirror, this is how it would look like, right? So this is the pole, this is the rough side, and this is the inside is the reflecting side. Okay, what are the things given? An object 4 cm in size. An object is usually placed erect. The height of the object is given as 4 cm. Okay, so this is positive in the upward direction. So object size h will be positive 4 cm. Okay, is placed at 25 cm in front of the mirror. So you see this is 25 cm in front of the mirror. Okay, so is it to the right or the left? It is to the left side, no? So this will be negative. It will be negative 25 cm. The focal length 15 cm. The focal length of a concave mirror, the focus is on the inside. It is given as 15. Okay, so that will also be negative 15 cm. You have to find out at what distance from the mirror should a screen be placed in order to obtain a sharp image. You know, whenever you are getting an image out of a mirror, you have to adjust the screen so that it becomes perfect. I think you have done the experiment at school also. You adjust the screen where, at first the image appears blurry, and then you adjust the screen a little bit, or you adjust that much enough where the image formed on the screen is perfectly sharp. Okay, it is simply asking you the image distance. Okay, nothing else. It's asking you at what distance should a screen be placed. It's asking you the image distance. So image distance v, I don't know, and find the nature and size of the image. Size is asked, so h is also here. You have to find out the height of the image. So image is mostly inverted, so you have to find out this height also. So please draw it. We'll proceed with the question now. Okay. What is this? It's a mirror again. So mirror formula, write mirror formula. 1 by v. Mirror is a positive thing in my life. Very good. Is 1 by f. So 1 by v will be, I don't know, image distance 1 by v, let it be there, plus minus 1 by 25, or 1 by minus 25 is 1 by minus 15. Okay, so let this go to the other side. So you get 1 by v is equal to 1 by minus 15. This is minus, when it goes to the other side becomes positive 25. So what is the LCM? LCM is 75. 15 into 5 is 75, and 3 is 25. 25 into 3 is 17. So the answer is minus 2 by 75. Now this is 1 by v. So v will be, you invert it, it will be 75 minus 75 by 2 or you can write minus 37.5 centimeter. Now that is the image distance. Now let's find out size of the image. Okay, so size is the h dash is what they're asking. So do I know the magnification? Because magnification is the only formula where I know where I can use this h dash. So magnification is not given, but I can find it out by using v by u. Okay, this is positive and this becomes negative. Is h dash by h is same as h dash by h. Okay, so can I substitute values and get the answer here? Minus v, that is minus of minus 37.5 divided by, how much is u? U is minus 25 is equal to h dash, I don't know, by height of the image is given as 4. Okay, so this minus minus cancels, so I get minus 37.5. I'll write it as minus 75 by 2 into 25 is equal to h dash by 4. Okay, so this is 3 and this is 2, or we get h dash is equal to 2 into minus 3 is minus 6 centimeters. Okay, so something is minus here. The h dash is minus, which means I'll draw the figure again and again and again. Okay, no problem drawing it again. Okay, so this is a concave mirror. The image was positive, so it is on the top. Now h dash, the size of the image, is given as negative. Okay, because it's downwards. So you can say the image is inverted also. It's inverted. Okay, now what is the magnification? Magnification m is size of the image. I've already found out. No, find the nature. Nature is real, inverted, and okay, h dash by h. It's already given that it's enlarged because h dash is 6, h was only 4. So when you solve it, you get it as 1.5. That is at least 150%. Okay, so it's enlarged also. It's an enlarged image. Okay, so all things you have, it is real. You found out position is not asked anywhere. So it is real, it is inverted, and it is enlarged. With that, this question is also finished. Okay, yeah, let's go to lenses questions now. Okay, here is example number 3, which is the first question on lenses. It says a concave lens has focal length of 15 centimeter. At what distance should the object from the lens be placed so that it forms an image of 10 image at 10 centimeter from the lens? Also, find the magnification produced by the lens. Okay, no problem. So it says we have a concave lens here. Okay, so we have a concave lens. This is the optical center, or I'll simply mark O here. O. Okay, it simply marks O. Is given the focal length of 15 centimeter. I told you, in case of a concave lens, if you draw a line parallel, it always appears to diverge away from the focus. So this is the focus that you have to consider. It is on the left side of the lens. So focal length f will be minus 15 centimeter. And also, at what distance should the object from the lens be placed so that it forms an image at 10 centimeters. So you know that if an object is placed somewhere here, you know that it is always diverging towards the right side. Okay, so there is no image formed on the right side of the lens. Always the image formed in case of a concave lens will be virtual. That will be on the same side as that of the object. It will also be on the left side. So it forms an image at 10 centimeter means, I told you, right, there is no possibility because it's always diverging. The image will be on the left side. So the image distance V is also 10 centimeter. Okay, now you have to find the object distance. See, at what distance should the object be placed? Okay, so object distance I don't know. Let it be there. Find the magnification of the lens. Before we go, let's write the lens formula. Lens formula. This is how you approach questions for your exam also. You have to write everything that is given in the question. Lens formula is, lens is something that you don't like to wear. So 1 by V minus 1 by U, it's a negative thing, equal to 1 by F. Or 1 by U is equal to 1 by V minus 1 by F. Alright, so what is 1 by V? Is 1 by minus 10 minus 1 by minus 15. So this minus minus cancels, this becomes plus. So let's take the LCM as 30. Okay, so minus 30 actually. So 10 into 3 and 15 into minus 2 is minus 1 by 30, or we get U is equal to minus 30 centimeter. So the object is also on the left side, that was very obvious. Now you have to find out the magnification. Okay, what is the formula for magnification? We know formula for magnification M. If this is negative here, then magnification is simply V by U. How much is V given? Minus 10, and U is minus 30, or it will be 0.1 by 3 or 0.33. 0.33 means it's only 33%. So the image is diminished. If it's more than 100%, then I can say, yeah, it's enlarged, but here it is less than 100%, it is 33% of the object, so the image is diminished. Okay, so please note down, and let's go to question number 4. Okay, here is question number 4. It says a 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. It's a convex lens, focal length is given as 10 centimeter. The distance of the object from the lens is 15 centimeter. Find the nature, position and size of the image. Also find its magnification. It's a convex lens. So how do you draw a convex lens? So here is a convex lens given, and it has a focal length of 10 centimeter. I told you, in case of a convex lens, after refraction, it moves to the focus on the right. Okay, so the right side focus is taken into consideration. It is given as how much? 10 centimeter. Okay, so the focal length, is it positive or negative? It is on the right side of the lens, so it is positive 10 centimeter. Okay, the height of the object is also given, a 2 centimeter tall object. So the object is usually placed erect. Nobody places the object inverted. So the height is given as positive 2 centimeter. Okay. The distance of the object from the lens is 15 centimeter. So this is 15 centimeter. Okay. That is towards the left. So the object distance U is equal to minus 15 centimeter. You have to find out the position, size, nature, everything. Okay, let's see. So let's apply lens formula. Lens formula. Lens is something that I don't like in my life, so it's a negative thing. 1 by V minus 1 by U equal to 1 by F. 1 by V is what I have to find out. So 1 by V is equal to 1 by F plus 1 by U. Now substitute values, you get 1 by 10 minus 1 by 15. So again, LCM is 30. 10 3 times, 15 2 times is correct? Yeah, 30. So 1 by V is 1 by 30. So V is equal to, you invert it, it is positive 30 centimeter. Okay, V is on the right side. So that is given, that you just identified. So this is a lens. You would see object is here, and it has gone to the right side. This is 15, so this is at 30, at least 2 times far away. Okay, and the other will be like this. It is obviously going to be inverted, but you can't say decided yet. You have to show it with mathematical calculation. So V is positive. It's at a distance 30 centimeter. It is on the right side. It is real. Okay, it can be collected on a screen. The next thing is to size of the image. Find the size of the image and its magnification. So I have V and I have U. So magnification is equal to, if this is negative here, magnification will be positive, V by U. So how much is V? 30. And U is minus 15. Okay, right. So magnification is -2. Minus you don't need to consider, but let's say you have to find out the height of the image. This magnification is also same as h dash by h. So that is h is it given? Yeah. H is given as h dash by 2 is equal to how much is magnification given? Magnification is -2 is h dash by 2, or you get h dash is equal to -4 centimeter, which means negative sign means it is downward. Negative sign, negative means it is inverted. Okay, the height is negative, which means the image is inverted, and then we have magnification 2. This minus you don't need to consider. Okay, this minus means height is negative, but 2 means it is 200%. It is enlarged image. Okay, it is an enlarged image. So what are the things we'll write? The nature, it is real. Position, you have V is equal to 30 centimeter to the right of the lens. Size of the image is 4 centimeter, and magnification is 2. I just marked it in the question itself, but when you're writing the answer, you have to write everything. You have to specify everything and write. Like magnification is 2, height h dash, height of the image is -4 centimeter, it is inverted, and it is real. With that, this question is finished, and in the next video we will do some extra questions. So till then, please note it down. Bye bye.